All right, this is the second day of section 4. And and we're going to start with some application questions. So you need to jump in your notes to ENLF 7. So it says, assume the United States national debt modeled can be modeled by this formula, where X represents the years since 1900 and Y represents the debt in billions. So we need to make sure we understand that this is not saying that we have a 5-cent debt. That's saying that we have that 5 times a billion. So it would be like a $50 million debt in 1900. Okay. And so we need to think about that when we're doing our answers. So the first question says, is this a growth or a decay? So let's just kind of get our head wrapped around this. Is this a growth or a decay? To know the answer to that question, you're going to look right here. That number is bigger than 1, so it's a growth. And it wants to know what the factor is. The factor is whatever that number is. So whatever's inside the parentheses is your factor. To find the growth rate, you have to figure out how far it is away from 1. So you're going to do 1.1306727, and you're going to minus 1, and you get 0.1306727, but that's not a rate. So you're going to have to move the decimal 2 places, and my answer is 13.06727%. So that is my rate. Okay, I will not accept the 0.13. If I ask for a rate, I want the percentage. Okay, so now it's still continued. It's saying, according to the model, when will the debt be $1 trillion, which is 1,000 billion? So it's basically telling me that it wants me to put and figure out 0.051517 times this stuff to the x. So when I do this, I would divide by this number. And that is what I'm actually I just need a little bit more room. So I'm just gonna come down right here. Just so I have a little bit more room, we'll put that here. So I would have 1,000 equals 0.051517 times 1.1306727 to the x. My variable is in the exponent, which means I'm going to need logs, but you can't log from here. So you first have to divide by this. And let me take out my calculator. I know you can't see it, so you're just gonna have to trust me. And it's not open, so it's gonna take a second here. Sorry, guys. It's like you're in class, right? And this is what happens. So my calculator is loading. And trying to get out of here. All right. It's like zoomed in there. Now I can see. So I'm going to do 1,000 divided by 0.051517, and I got 1941 1.1. So now that I have it written in this form, now I can do the log. Oops. So it would be the log base 1.13 of 19411.1, and that's going to be my answer. So I'm taking my calculator and I'm doing the log on my calculator, and I'm sorry, I would do this with me to make sure, since I can't show you both screens. 1306727, and then this would be 1941.1. So I get 80 we'll say 4 years. Okay, so that would be my answer for the first question. Okay, now on question 2, it says, what is the doubling time of the national debt? So we did doubling time yesterday. So basically, aren't I going to double this number? That's up at the top. Aren't I going to double that number and then equal it to whatever that number is doubled? So 0.051517. And if I double it, it's going to be equal to 0.103034. But then aren't I going to divide by that number? So So this is what happened in class in both of my classes yesterday. Somebody raised their hand in both classes, and that's kind of the bad thing about being online. And so I just want to talk about this. And they were like, wait a minute, if you double it and then divide, aren't you always going to get 2 after you do that? So isn't it always just going to be 2 right here? Do I have to show all those steps? And you've been in school long enough. You probably know exactly what classmates it were that were like, do I really have to show all the steps? I'm going to divide anyway. No, you're fine. So you do that. So I'm going to do the log base 1.13 ... of 2, and that's going to equal x. So I'm going to do the log base that stuff of 2, and my answer is 5.64 years. Okay, and according to this model, what is the national debt this year? So this was in 1900, this formula was. So then if I did 2020, wouldn't I take up here and put 120 in? So I'm basically going to do 0.051517, 1.1306727 to the 120th. So I'm going to do the 0.051517, 1517 times 1.1306727 to the 120. So I'm going to take that to the 120, and I get 129,533. So that is basically saying, because that's going to be like a trillion, so that's going to be 129 trillion is the national debt. And so I think that in your textbook it says something like, is it accurate or whatever? So you have, like, you are so lucky compared to when I first started teaching. So I could just Google national debt and U.S. national debt in real time. They have one of these for population. Holy cow, I think we're pretty close if you look over in the left-hand side. Okay, and so I don't know, there's a lot of information on that page, so who knows? But if it did ask you, just Google it and see. Okay, so here is example 5. It says a carbon-14 is an isotope of carbon that's formed when radiation from the sun strikes the ordinary carbon dioxide in the atmosphere. Trees, which get their carbon-14 from the air, contain small amount of carbon-14. Once a tree is cut down, no more carbon-14 is formed, and the amount that is present begins to decay slowly. The half-life, so this is important, the half-life of carbon-14 is 5,730 years. Okay, so all of this information is important, and so I brought it down into this next page so we could see it. Really all we needed was the half-life. So it says, find an equation that models the percentage of carbon-14 in a sample wood. It gives you a hint. Consider that at time 0, there's 100%, so that's my initial value. And at time 5,730, it's 50%. Okay, so what I'm going to do is I'm going to come down here and just use this room. I'm going to do this for the first one. Okay, so I know that 50% of it was there, and I know this is a 1 minus r to the 5730. So the first thing I would do is divide by 100, so that's 0.5. 1 plus r to the 5730. Well, my exponent is not a variable, so I don't need logs. I need to actually 5730 root this. So I'm going to take the 5730 root of 0.5, and I get this should say 1 minus r. I just noticed that. Thank you for all of you that email me my mistakes. I just can't do 47 takes of these, and so I'm going to make some mistakes. So this is 0.999879, and that's what 1 minus r equals. So that's basically what I could put in the parentheses. So it wants me to write an equation, so I'm going to say y equals 100 times 0.999879 to the x, okay? And I know I told you guys to round it 4 places, but since this is such a tiny decimal, I would probably round it 6, Okay, so then on the next thing, and I'm going to show you that here in a second. I'll actually probably put this on the other calculator so that you guys can see it. Oh, it's right there so I can see. So I can put it on the Desmos so you can see. So it says a piece of wood containing 48.37 of its original value. So that would be 100. So this would be 0.999879 to the X. How long ago did the tree die? So isn't the first thing I'm going to do is to divide by 100. So I get 0.4837 equals 0.999879 to the X. So then I would log that. Okay, so I'm going to do 0.999879 of 0.4837 equals X. And so now I'm going to show this to you guys. 0.4. I'm going to show this to you on Desmos just because I just want you to see why, since it's such a tiny rate, you actually want to round it 6 places. I'm going to go like this just so you can see it. It's a little bit bigger. Tyler showed me that today. So if I do the log, so I'm going to go functions, I'm going to go log. Oh no, wrong log. Sorry, I'm not used to using this. The log base. And so now we got 0.999879 of 0.4837. And if you look, I get 6,000 years. If you look right there, you get 6,000 years. Because I know someone's going to ask me, I thought you said we only had to round it 4 decimal places. So then if I went 0.9999 of 0.4837, I'm off by 1,000 years. I'm off on my tree's guess of my tree by 1,000 years. Okay. And so, like, even if I did, like, instead of just doing this, if I just did 0.99, okay, I'm off by 6,000 years. Like, it's just, you, on something like this that is really decaying, like on a dinosaur bone, you're going to actually use 4 to 6 decimal points. And so, on these application questions, I would use the whole decimal. Okay, all right, so with that being said, the altitude of an airplane is calculated. So if I were you, go ahead and pause this and see if you can do it on your own, and then start it up again and see if you get it. Because this is what we'll do in class. We've worked the first couple together, and now I'm going to pause this and I'm going to say, okay, you guys try it. Okay, so pause and try it. So on this question, the altitude of an airplane is calculated by the pressure on the surface. The pressure is exponentially related to the plane's height off the earth. So then it says ground level is 14.7 and 2 miles is 9.46. So I know that ground level is 14.7 and I know that 2 miles is 9.46. Yes? So I can write an exponential equation because I have the initial point. I know that 14.7 is the initial point. I know this is a decay because I'm losing value. And I have an X and a Y because I have this other point. So I'm going to plug in for my Y 9.46 and for my X 2. So I'm going to take 9.46 and I'm going to divide by 14.7. And then I'm going to, so I got 0.643537 equals 1 minus r squared. So now I'm going to undo squaring something. So I'm going to square root it. And I get 1 minus r equals 0.8022. So my answer on this would be y equals 14.7 times 0.8022 to the x. So that would be my equation, okay? Then it says, what is the pressure at 12,000 feet, which is 1 mile is 5,280. So I need this to do in miles. So I'm going to do 12,000 feet divided by 5,280. So 12,000 divided by 5,280, and sorry, it's going to be 2.2727 miles. So I'm going to basically take this and put it into my x for my equation because that's what my miles is. So 14.7 parentheses that 0.8 stuff to the 2.27, and I ended up getting 8.91 pressure. What's the pressure measured in? Pounds per square inch. Pounds per inch square. Okay? And so that was my answer for that one. Then it says, what is the altitude of an airplane if the pressure is 3.65? So that means I'm putting 3.65 in for my y. So my initial value is 14.7, and then it's 0.8022 to the x. So the first thing I would do is divide by 14.7. So I'd have 3.65 divided by 14.7, and I got 0.248299 equals this stuff. So then I'm going to log base 0.8022 of 0.248299 equals x. So I'm doing the log of that point. I was just trying to bring it down so I didn't have to type it. Of this. And so I got 6.32 miles. Okay, so you can find, whether you know the pounds per square inch or you know the miles, you can find the other one. Sometimes you need logs, sometimes you don't. It depends on what you're given. Okay, now on this one, this is an example of logistic growth, and I am not going to make you write one of these. You will have to write them in your 1450 in the pre-calc class. You're going to actually be given a story problem and have to write that equation. Okay, and I just want to type this in here so I can go back and forth. Plus 99. Okay, so what it says is this gives the total, blah, blah, blah. Find each value and give its real world meaning. So the first thing it wants me to do is find f of 20. So I'm just going to go ahead and find f of 20. So f of 20 would be 12,000 divided by 1 plus 499 times 1.09 to the negative 20. So my answer is 133.27. So let's see what it's about. 133. Find, give the total sales X days after the release. So my X value is days. So it's 20 days after the release. I had 133.27 total sales. Probably want to round that to a whole number. Total gives the total sales. No, I think it would be money. And so then they want me to do the same thing, but they want me to put 80 in. So I'm going to go back to here. I think I can just delete that and put 80 because it would be a minus 80. So I get 7,969.17. 7,969 I forgot already. 0.17. Okay, so now it says find when f of x equals 6,000. Okay, and there is no way I'm going to put 6,000 in there and solve that thing because you would have a calculator. So what I'm going to do now is I'm going to come here and I'm going to not make this an equation anymore. Put an x in, not a 0x. And I'm going to say y equals. So it should give me my graph. There she is. Okay. And so it kind of goes up exponentially, but I do want to show you this. I'm just not good at Desmos. I want this just to come down because I think it flattens out. Well, I know it flattens out. This is why. There. Okay. It flattens out at 12,000. So, and I want this, I'm gonna get this out a little wider because we're going by days here. This is not, I might have to, there. I don't know what I'm doing. Because, I mean, we're talking days. There. So it's going to flatten out because here was our 20 days. And we got, and I can go up this thing. So when we put 80 in, we got an answer. Trying to get there. It's close to that. I just can't see, my hands in the way. So we got that answer. We got 7,900 and blah, 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 0.17. Okay, so this thing flattens out. It definitely levels out. There we go. And it flattens out if you look at this line at 12,000. So the question asks, find when f of x equals 6,000. So then I can just take and I can put 6,000. I'm just looking for 6,000, which would be around in here. And it's not letting me. Okay, this is so hard to do because wherever I put my finger, it puts the point on the other side. So I can't do this. I'm going to try using the pen. There. So I want 6,000 and as close as I can get. That's a lot. So you know what? Miss Williams is going to be smarter than that. I'm going to return and do y equals 6,000. I don't know why I didn't think of that before because I'm trying to hurry and make these videos. And now I can give you the answer, 72.091. And you can do that on your own calculator. You can put another line in there and get that answer. So I knew that my answer, forgot it already, was 72.1. So the answer to this is 72.1. Then it says graph the equation in a window large enough to see the overall behavior. Use your graph to describe how the number of games sold each day changes. Does it sound reasonable? So it grows, but then it levels off at 12,000, which really is realistic. Like if you think about games, like everybody's gonna, like nobody's gonna have it, right? Because it's a brand new game and maybe nobody's heard of it before. And then people start playing it and then they really, really like it. So word of mouth, everybody buys it, but then everybody owns it. So now it levels off because you're not gonna buy two of a video game, like one is enough. So leveling off makes sense, okay? All right, so if we take a look at this, it says all humans start. So again, go ahead and pause this and try this one on your own, and then we'll work it together. All right, so it says all humans start as a single cell. This cell splits into two cells, then into two more, then into two, and so on. Write an equation that shows this growth. So basically, we all start as a single cell, and then we all double. Right? So wouldn't my equation be y equals 2 to the x? Okay. After how many divisions was there more than 1 million cells? So wouldn't I put 1 million, right? I would put 1 million in for y, and then I would do the log base 2 of 1 million. So I'm going to do the log base 2 of, the log base 2 of 1 million. And my answer is 19.93 splits. So basically it's going to take, to be more than 1 million, it's going to take 20 splits. Let's be realistic, right? It's going to take 20 splits. Now you can check that by doing 2 to the 20th, which comes out as 1,048,000. So that kind of tells you that that's right. Okay, so that's the notes for today. The rest of the notes were, I kind of gave you yesterday with the inequalities, and we're going to go over answers and stuff. Please make sure that you're working on your project over the weekend. I am docking everybody that doesn't turn it in by Tuesday. I don't care if you're online or in school, you still can do the project. I put 2 movies in the Google Classroom about the project, and I expect to get it emailed to me on Tuesday. So you can ask me questions. I know that this hasn't been easy, and I know a lot of you have been working hard. So if you aren't in school, please, 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 if you're confused on this, get a hold of me. That is my job to help you. But if I don't hear from you, I am assuming that you are good to go. So please let me know if you need any help.